Hello guys, welcome to the class. Hi Preeti, hi Mihir. How are you guys? So guys, today we are going to do the second session of sets, relations and functions. I believe you must have attended the first session in which we discussed about the domain and the range stuff. And today I'll be starting with some of the composition concept. Now, before that, let me tell you that this topic has a good weightage both in terms of JEE mains in advance. So basically, you can expect at least 4% of the questions from the functions. And if I tell you what exactly the composition concept is all about, so we'll help it to explain with the help of a diagram. Okay, so let's say the square box is my function. Function is what? It's basically a machine in which we send one input and we get one output. Now, let's say this is my function. Okay, I'll take any two functions. Let's say if I take x square and sine x. So if I take fx is equals to x square and I take gx as the another function as sine x. Now, guys, if I say FOG, that means FOG. So what exactly means in the function fx, I'm sending gx as the input. Okay, so let's say this is my function fx. So guys, what's going input in this? Gx is going as the input. So before that, I need to make the function gx as well. So let's say this is my gx function. So in gx, there's nothing more. It's just that in gx, x is going as the input. So I will make x as the input out here. And gx is what? Sine x. So sine x is coming as the output. Now in fx, what will go as the input? X will not go. Is that sine x will go as the input. And fx is the function which squares anything which comes as the input. So as simple as that, I'll be getting sine x whole square. Okay, why? Because the function fx has the property, it makes the square of any function that comes input for it. In this case, we were not getting x as the function input, we were getting sine x as the input. So we will now go to some of the JEE questions which make the use of this particular concept. So in year 2011, we had a function composition question which had fx is equals to x square and gx equals to sine x. Now, some of you might consider this to be a very difficult question, seeing FOG, GOOFX, but it's not. If you are very clear with the concept of composition, you have to break the question into step by step and start pursuing it, and it will become really easy for you guys. Let's see how we do. So first of all, what is given? Like GOF. So first, let's try to find GOF. So GOF means that I have x, which goes as the input in fx. Okay. So what I get output? Fx is x square. So I get my output as x square. Now that goes as the input in G, because after f, the second functions come out to be G. So if I write gx, so what will I get as the output? As gx is sine x, so x square is going as the input. So g will just put sine over there, and I'll be end up getting sine of x square. Now, guys, you should be very clear of this. Sine square x and sine x square are two different things. In sine square x, x is there, and the square of the entire function is done. But in case of sine x square is the input, and it's like inside sine we have the x square. Now, again we have 1g more. So again we have gx. Now what will be the output? It will be again sine of what was the input? My input was sine x square. So this will go sine of sine x square. Now, after taking two g's, we have again f with us. So this will go as the input in f. And what fs does? Fs just squares whatever comes as the input. So it will become sine of sine x square, and we will square this entire quantity. So guys, if you see, if we do step by step, then we eliminate the chance of making any mistake. Plus, the question becomes really easy. So I'm repeating it again. I'm taking x as the input. So fx is the output. Like x square comes, then x square goes as the input in gx. So that becomes sine x square. Then again it goes into gx. So again it becomes sine of x square. And then again goes into f. So it becomes sine of sine x square whole square. Now I'll be finding what is my right hand side. So right hand side is GOF. So again, we'll be drawing the new diagram in which x is going as the input. So I'll be having f of x. So what it was, f of x, and then it was g. So x square comes as the output. Then we have g of x. So this will be again sine of x square. Then we have one more g with us. See, f we have done g, and then one more g. So again, we will be sending it back to gx. So what will be my output? Sine of sine x square. Okay. Now, as per given in the question, these both things are equal. So I can equate both of them, the outputs which are coming through the two composition machines. So what I will do is simply I'll equate both of them. So that will turn out to be sine of sine x square whole square equals to sine of sine x square. Now, if I take the term on the right hand side to the left hand side, so this will become sine of sine x square whole square minus sine of sine x square equals to 0. Now, guys, just assume sine of sine x square as one term and try to take it out as common. Okay, if I assume this entire thing as one term and take it out common, because I'm having its power 2 in the first term. So I'll simply take this as common. So I'll be getting sine of sine x square Then again in the bracket at this power 2. So one power will be left out in the bracket. So I'll be having sine of sine x square minus 1 equals to 0. Now this has converted into a very similar thing which we have done in many of the questions. Like if two quantities are 0, their product is 0. So like either A is 0 or the second quantity B is 0. So the first is sine of sine x square is 0. So either sine of sine x square equals to 0, or we have sine of sine x square minus 1 equals to 0. We have sine of sine x square minus 1 equals to 0. So we'll try and solve both of them, and let's see if anyone gets eliminated or like that. Now, the first one says the sine of sine x square is 0. So obviously sine of x square has to be 0, or sine of x square, because if you remember the graph of sine, guys, I'll draw for you the graph of sine for those of you who might not remember. Now see, at what points does the sine of x give me 0? At 0 and at pi and at 2 pi. So basically at n pi, I get the value of sine x as 0. So if I talk about the principal value, so basically what value will end up getting it 0? That sine of x square is 0. Okay. Now, if I talk about the second term, which says the sine of x square minus 1 equals to 0. So if I send the minus 1 on the right-hand side, I'll be left out with sine of sine x square equals to 1. Okay. Now, just think this particular thing. Sine of x square is equals to like pi by 2. Because I get the value of 1 at pi by 2. So I can say that sine of x square is equals to pi by 2. Now, guys, this is a very important concept out over here. As you know, this particular quantity, pi by 2, pi is like 3.14 and 2. So if you divide, this quantity will come greater than 1. But if you know that sine function never gives a value more than 1 and never less than minus 1, because its ranges between minus 1 and 1. So the second value will be rejected. So this case is rejected because it's end up getting sine function giving pi by 2. So that's a value greater than 1. So that's not possible. So obviously we are left out with this option, and x square is basically equals to n pi, because I'm getting zeros at the various options. Okay, Sri Harin is not understanding why rejected. Okay, if you know the concept of range, can sine function can give anytime value more than 1? See, pi by 2 is something which is more than 1. Pi is 3 point something and 2. If you divide 3.14 with 2, you'll be getting a quantity more than 1. So that's why we are not taking this value is getting rejected. So basically we have x squared equals to n pi, and x will be equals to, as per the options, we have x is equals to square root plus minus under root n pi. Now some of you might be considering why it is plus minus. So x is basically equals to plus minus under root of n pi. Why plus minus? Because a simple concept is like this, because if we take square root on both the sides, we get under root of x squared. So that's basically equals to mod of x. So this is a very basic concept in which many students get stuck if they're not clear. So this is also one of the concept which needs to be taken care of while doing a question. So if you see, the A option is pretty fine because 0 is also included, and at 0 also we are getting the particular values. So we'll be end up getting A option. I believe this question was very clear to every one of you. So we can proceed further with the next question. Okay. Now looking at it, it seems really tough question. It says that let f be a real valued function defined on the interval -1 to 1 such that e raised to the power negative x fx is equals to 2 plus integration of 0 to x under root of t squared t raised to the power 4 plus 1 into dt. Okay. Now what is talking about? It's talking about f inverse, and it's also talking about differentiation. Okay, so it's talking about differentiation. So first of all, let's try and differentiate the expression which is given to us. That is e raised to the power minus x fx plus 2 plus integration of 0 to x under root t raised to the power 4 plus 1 dt. So if I differentiate this particular expression, what will I get? Let's see. So e raised to the power minus x f dash x. I'm using the product rules, guys. I believe everyone must be aware of the product rule. Then I first differentiated the fx, so it became f dash x. Then I'll differentiate e raised to the power minus x. So differentiation of e raised to the power minus x is e raised to the power minus x, and then by chain rule I'll differentiate minus x. So minus 1 will come out, and so minus 1, if it comes out, so it will be minus of e raised to the power minus x into fx. Plus on the right hand side, differentiation of 2 with 0 and its integration, so it will just nullify, and I'll put the upper limit, that is x raised to the power 4, and so this will be simply x raised to the power 4 plus 1. Now what can I do is I can simply take e raised to the power minus x common. So if I take e raised to the power minus x common, I'll be end up getting f dash x minus of f of x equals to under root of x raised to the power 4 plus 1. Now if e raised to the power minus x is in the left hand side, if I take it to the right hand side, so the power will be positive out there. So I'll be having f dash x minus fx equals to e raised to the power x into x raised to the power 4 plus 1. Now, in order to find expression for f dash x, I'll take fx to the right hand side. So I'll be having f dash x is equals to fx plus e raised to the power x under root x raised to the power 4 plus 1. Okay, this is something which we will keep separately because this is going to help us in getting the f dash x. Now, again, it's a concept of beautiful concept of composition. Now, we are talking about F inverse differentiation. So guys, what is F inverse if I talk about? Can I write F inverse as like this? F inverse f of x is equals to x, because f inverse and f will cancel off and we are left out with x. I'm doing this so because in the question it is asked f inverse differentiation. So I need to resort to something of f inverse. And f dash x I already have in the expression before. So if I differentiate this, so by chain rule, I'll be having f inverse fx dash, and then I'll be having f dash x by chain rule, guys. And differentiation of x is 1. Now, I need the expression f inverse and dash. Just try to think. It's correlating with what we have exactly in the question. F inverse and differentiation. So over here, also we have f inverse and differentiation. So I'll just take f dash x in the denominator of the right-hand side. So what I'll be left out with is f inverse fx dash, which denotes differentiation, is equals to f dash x. Okay, and f dash x we have already calculated up in the red. So I have f dash x as fx plus e raised to the power x under root x raised to the power 4 plus 1. So 1 upon fx plus e raised to the power x, x raised to the power 4 plus 1. So this is my simplified form. Now just try and see what's going input into the f inverse. The input which is going into f inverse is 2. So f inverse input is going as 2. Okay, so f inverse input is going 2, but over here we have fx as the input. So I'll write fx. Now fx is giving 2 as the output because I need to send 2 as the input to f inverse. So what basically I can write? I can write it like this also. Fx is there. So I want output as 2. So I need to figure out what's the value of this input x, which is giving output as 2. So again, we'll go back to our expression. See, it's very crystal clear written. 2 plus integration from 0 to x. If I make x as 0, nothing more to think about, guys. If I simply make x as 0 out there in the expression, what will I get? E raised to the power 0 is 1. So that will be 1. And this will be f of 0 equals to limit, like integration from 0 to 0 is 0. So 2. Very easy, given in the question. So f of 0 is giving me 2. So in fx, if I send input as 0, or rather I place the value of x as 0, I get output as 2. So x is 0 over here. Okay, now this is practically solved. If you see f inverse, or if I highlight this particular expression, if I put x as 0, so what it will convert to? It will convert to f inverse f0 dash is equals to 1 upon f0 plus x is 0. So e raised to the power 0 is 1. 1 into 0 plus 1 under root, that will again be 1. Now what is this? f0. Guys, f0 is 2. So what I'll be end up getting is f inverse 2 dash is equals to f0 is 2. So 1 upon 2 plus 1. So that is 1 by 3. And we have the option with us. That's 1 by 3. So I believe, guys, it was looking at as a difficult question on the first instant. But if you go step by step using the concept of composition, that, okay, what exactly I need to send input into the F inverse so that I get 2 as the output over there. So I broke it down that you need to send 0 into fx, so that will give 2 as the output, and that will eventually enter as input into the F inverse. So I believe it's clear to Preeti. You can watch the recording. So this question is available. If you look from the beginning, it will be very clear to you that how we thought about. We first of all differentiated the given expression. Because why we differentiated? Because in the question it was asking about differentiation, plus it was asking about the inverse. So we formed another equation that was f inverse fx is equals to x. Then we differentiated that particular equation as well. And then with the help of chain rule, we got f inverse fx dash is equals to 1 upon f dash x. And f dash x could be very easily substituted with the help of the above equation. That was fx plus e raised to the power x under root x raised to the power 4 plus 1. And then we got that we have to put x as 0 so that we get 2 as the output from fx. Great, guys, if you have understood it. Okay, now coming to the question which came in 2000. So this was a simple question. Let's see how we can solve it in the minimum possible steps. So f theta is sine theta, and it's not a composition, it's basically multiplied. So f theta I can write sine theta, and sine 3 theta is equals to 3 sine theta minus 4 sine cube theta. We can directly replace it. Okay, so sine theta, and I have 4 sine theta, because sine theta and 3 sine theta will get it added up in order to make 4 sine theta minus 4 sine cube theta. Now, guys, what will come out of it as common? 4 sine theta will come common. So I'll be having 4 sine square theta outwards. And inside the bracket, I'll be having 1 minus sine square theta. Now, everyone knows that 1 minus sine square theta is cos square theta. So there's nothing difficult in this. So I'll be having 4 sine square theta into cos square theta. Now, if I just simplify this, if I write it 2 sine theta cos theta whole square. Why? Because if a number is square, then obviously it's greater than equal to 0. Square can never be negative. And it is like 2 sine theta cos theta is like sine 2 theta. So sine 2 theta whole square. And we know that this has to be greater than equal to 0 for all the numbers on the number line. So we are end up getting C option. It's greater than equal to 0 for all the real theta. Now, coming to the last question for the day, guys, which is again a trigonometric and plus using the concept of function. So it's using the formulas which are generally taught in the grades 9th and 10th. If you see, fk is equals to 1 upon k sine raised to the power k plus cos raised to the power k. Okay, so first we'll find what's f4, then we'll find what's f6. So let's see what is f4. So f4 is equals to 1 by 4 sine raised to the power 4x plus cos raised to the power 4x. Okay. Now, whenever you see such kind of things, just remember sine square x plus cos square x always makes the question easier. So try to make use of the identity in whenever expression you find in terms of squares or powers, even powers. So I can write it like this. Can I not write it like this? Sine square x whole square plus cos square x whole square. Okay, and if I add and subtract 2 sine square x cos square x, and I subtract minus 2 sine square x, so that won't make any difference. Now, the whole idea behind this is like I can write this particular expression as sine square x plus cos square x whole square. And that will simplify to something really interesting. 1 by 4 sine square x plus cos square x whole square minus 2 sine square x cos square x. Okay, what is this? Everyone knows 1. So I'll write it like this: 1 by 4, 1 minus 2 sine square x cos square x. We have ended up finding the f4. Now it comes to finding the value of f6. So let's start finding the value of f6. So f6 is equals to 1 by 6 sine raised to the power 6 x plus cos raised to the power 6x. Now we again move to our fundamentals that we need sine square x plus cos square x anyhow. So I'll convert it into sine square x cube plus cos square x cube. So if I write it 1 by 6 sine square x whole cube plus cos square x whole cube. Now a plus b whole cube is a cube plus b cube plus 3ab a plus b. So if I write a cube plus b cube, so that will be equivalent to a plus b whole cube and plus 3ab. A plus b will shift to the left hand side. Yeah, Preeti is getting it right. So I can write it like this: sine square x plus cos square x whole cube minus of 3 sine square x cos square x, and in the bracket I have sine square x plus cos square x. Now, for some of you, it might seem complicated. So just try and correlate sine square x as A and cos square x as B, and then use the formula of A plus B whole cube. Then everything will be crystal clear to you guys. So this will be 1 by 6 sine square x plus cos square x 1. So I'll be having 1 minus 3 sine square x cos square x, and sine square x plus cos square x again 1. So I've also calculated f6. Now what's asked in the question is f4 minus f6. So f4 is 1 by 4 minus, sorry, 1 by 4. f4 minus f6 will be 1 by 4. In the bracket, I have 1 minus 2 sine square x cos square x. And f6 is minus 1 by 6. 1 minus 3 sine square x cos square x. So this will be equivalent to 1 by 4 minus 1 by 2 sine square x cos square x, and I'm having 1 by 6 minus 1 by 6 plus again 1 by 2, because 3 by 6 is 1 by 2 sine square x cos square x. So what will happen is this and this will cancel off, leaving me only with numbers. So I have 1 by 4 minus 1 by 6. So LCM is 12 and 3 minus 2. So that's 1 by 12. So I'm having the answer as 1 by 12. So guys, if I quickly give you the overview of what all we did today, we understood that even the complicated problems which involve many compositions can be converted into very easy questions if you simply focus on doing it step by step, that the input of one is going into the function and then output, so that eventually becomes the input for the other one. So if you go step by step, then question simplifies and it turns out to be much easier than what it seems to be. So guys, you can subscribe to the Meritnation and watch the videos for the various chapters and the past year JEE questions. Many of our faculty members will be taking those things. So guys, bye bye and all the best for your JEE preparation.